Thank you for watching this video. So in this video we're doing question 3 of November 2023, question paper mathematics paper 1, actually paper 2. This is analytical geometry. So I'll read the questions and then proceed to answer the questions that follow. So question 3. In the figure below, L, N, and S are vertices of a triangle having an angle of 90 degrees at L. Ln intersects the x-axis at K. Let me try to read this again. They are saying in the figure below, L, S, and N are vertices of a triangle right-angled at L. And Ln intersects the x-axis at K. So they're just telling you what you can see here. So you see you have L, S, and N. They form a triangle. And this triangle of yours is right-angled at L, which is this 90 degrees. It forms 90 degrees at L. That's what they're telling you. And they tell you that this line Ln, this one, intersects the x-axis at K. That's it. Done. That's all they're saying. Fine. So, 3.1. Calculate the length of SL. They wanted to find the length of SL, which is this distance here. So you know how to find the distance. 3.1. 3.1. The distance is equal to x1 minus x2 all squared plus y2 minus y1 all squared. So this is how you find the distance. So you need to find those coordinates. You want the distance SL, which is SL. So the coordinates of L are what? Are minus 4 and 1. And the coordinates of S are 4 and 5. So you want the distance between these 2 points. So you can say this is coordinate number 1, this is coordinate number 2. So the distance SL is equal to this. So you say x and x coordinate 2, x coordinate 2 is 4, minus x coordinate 1, which is minus 4, all squared, right? Plus y coordinate 2, which is 5, minus y coordinate 1, which is 1, all squared. So the distance SL is the answer to this. So you type that in the calculator and see the answer. So let's do that. Square root of 4 minus negative 4 all squared plus 5 minus 1 all squared. So the answer is 4 square root of 5. This is your answer. This is your distance for SL. SL is this distance here. You know it's 4 square root of 5. Here we go. Done. Go to the next one, 3.2. What are they saying at 3.2? At 3.2, they are saying, calculate the gradient of Sn. They want you to find the gradient of Sn. Where is Sn? Sn is this one. So they wanted to find the slope of this line here. Right? Fine. How do you find the slope of a gradient? Of slope between 2 points, right? You say your slope is equal to y2 minus y1 over x2 minus x1, right? What are these 2 points that you're talking about? It's S and N. S have coordinates 4 and 5, right? And N have coordinates minus 2 and minus 3. So you can say this is coordinate number 1 and this is coordinate number 2. So now if you want the gradient of Sn, you substitute those values here. So what is y number 2? Your y number 2 is minus 3. Minus y number 1, which is 5, divided by x number 2, which is minus 2, divided by x number 1, which is 4. So this comes out as minus 8 over minus 6. So this is 4 over 3 in simple terms. Therefore, your gradient of Sn is equal to 4 over 3. So you can come and enter this information here. You can say m of Sn is equal to 4 over 3. So I like calculating all answering all the questions and then fill them on my diagram so I can see everything that I might need. So it's good to put everything back here after calculating it so that you can always find it or you can always see it easily. No problem. So we found the gradient of Sn to be that. No problem. Let's move. They are saying calculate the size of theta, the angle of inclination of Sn. They want you to find the angle of theta, which is the angle of inclination of Sn. So this is 3.3, right? They want you to find the angle of inclination. So you know that m is equal to tan theta, which is what is your m? Is your m of Sn will be equal to tan theta, right? What is m of Sn? Is 4 over 3 is equal to tan theta. So theta is equal to arctan 4 over 3. Therefore, the theta is equal to whatever the answer is here. You punch that and see what your angle looks like. Arctangent 4 over 3. So you get that your theta is 53.13 degrees. Use the theta. Done. These questions are straightforward. You hope they ask you these questions all the time. So we move to 3.4. What are they saying at 3.4? Let's enter this information as well. So this is 53.13 is theta. So it's this angle here. Theta is called 53.13. I hope it is clear. So theta, which is that, is called 53.13. No problem. Done. So we move. They're saying calculate the size of n, the size of angle n in triangle LNS. So they want you to find this angle here n in this triangle, right? So there are few ways in which you can approach this. I'm just going to do all of them because I'm in a code mode today. I'm not going to do one, I'll do all of them. So, how do we do that? The first thing, we can say, okay, we want this angle n here. We can try to redraw this triangle. So you have a triangle like this. So you have 90 degrees here. This is L, this is S, this is N. And you want this angle here. You know this distance here, that is 4√5, right? You calculated this distance. It was the first question. You can find this distance here, right? After finding this distance here, you can use the trig ratios to find this distance, to find this angle that you want, n. So let's find this distance, Ln. L, if the coordinates what? -4 and 1, right? And n, the coordinates -2 and -3, right? No problem. So the distance of Ln would be equal to, you can say this is coordinate number 1, this is coordinate number 2. Say -2 minus 4 all squared plus, what is, then you say -3 minus 1 all squared. So you punch that, you will get the distance for Ln. So let's do that. 2 minus 94 all squared plus -3 minus 1 all squared. So you get that the distance for Ln is equal to 2√5, right? So you know that this distance here is 2 square root of 5. Fine. So you want this end here, n. So you know we have the opposite side and the adjacent side to this angle. So that's tangent. So tangent of angle n is equal to the opposite side, which is LS, over the adjacent side, which is Ln. So which is equal to what? It's 4 root 5 divided by 2 root 5. This and that go away, so you have 4 over 2. So a tangent of n is equal to 2. So angle n, which is what you're looking for, is called arctan of 2. What is arctan of 2? It is equal to 63.43 degrees. 63.43 degrees, which is, you have this angle here, n to be 63.43 degrees. Done. How to define this? You know, it was arctan of 2. That's how we found it. And this one here was arctan of 4 over 3. Done. So another way you can do it using the cosine rule. You can use the cosine rule. Cosine rule almost works every time. You use the cosine rule. Says a squared is equal to b squared plus c squared minus 2bc cos a. Right? But in this case, you want, actually, what you need in this case, you want to find, you need this length on the other side, right? You need this length, so you can use Pythagoras to find LS, NS. Let's use Pythagoras to find this side so that we have all the sides, right? So that we're only left with the angle that we want. So, because here, you need to, if you want the angle n, you need to have all the sides. But here you are missing one side, right? You're missing one side. The side that we're missing is what? The side that we're missing is NS. Let's find NS using Pythagoras. You say r squared is equal to x squared plus b squared, right? Which means r squared, which is the Pythagoras, which is NS. NS squared is equal to ln squared plus ls squared. So NS squared, NS is equal to the square root of this, which is 2 root 5 all squared plus 4 root 5 all squared. So NS is equal to the answer of this. So 2 root 5 all squared plus 4 root 5 all squared. So NS is equal to 10. So we know that this side is equal to 10 units, which is the same side as this. DNS is equal to 10 units. So you have all the sides now, right? You have all the sides. So you can use your cosine rule now, which means you want this angle, which is ls squared is equal to ln squared plus ns squared minus 2 ln ns cos n angle n. What is ls? ls is 4 root 5 all squared is equal to ln. What is ln? It's 2 root 5 all squared plus ns. What is ns? 10 all squared minus 2 into 2 root 5 into 10 cos n. So you solve for cos. So you find that cos n, angle n is equal to, solve for n here. So which means you know how to solve it. Transpose these two and divide by that. So we say 4 root 5 all squared minus 2 root 5 all squared minus 10 all squared divided by 2 to 2 root 5 into 10. So you get that this is equal to what? Minus, get this, that this is equal to, something doesn't look very good. 4 root 5 minus 10, oh, it should be negative here. So it's 5 root 5 over 5. Then you say n is equal to cos root 5 over 5. So you get that your angle n is equal to the answer of that. Cos, you got answer. This is 63.43. Done. Same answer, different ways. There's also another option that you can also explore for the same question. I'm going to clean this part and then we'll try to find the same angle for another form. Like I said, there's no need to do all of them, but as I said, my mood is not very bad today, so I can do all of them. So another way you can do it, you can say, okay, you still want this angle n here, right? Let me remove it here. This angle n. You can say, okay, I know what this angle is, because these are two vertical opposite angles. So it's 5, 3, 1, 3. Then you can find the gradient of this one here, right? And find the angle of inclination, which is this. Once you know this angle of inclination, you'll know what will be the angle you'll know what the angle inside will be, this angle here. So which is now on this small triangle here, you'll know two angles, this one and this one, and you'll be missing one. So you know that angles in a triangle are supplementary, so you'll be able to find what this is. So what you need to find the gradient of Ln. So let's say you find the gradient of Ln. M of Ln is equal to y2 minus y1 over x2 minus x1. What is L? L is minus 4 and 1 into n is minus 2 and minus 3. So you can say 1 is equal to number 2. So the gradient of Ln will be called what? It will be called minus 3 minus 1 divided by what? Minus 2 minus 4. So this becomes what? This becomes minus 4 over negative 2 plus 4. So this becomes minus 4 over 2. This becomes minus 2. Right? So this gradient is minus 2. Then find this angle of inclination that is here. Let's say this is K1. This is K number 2. Right? You want to find the angle of inclination K1. Now M of Ln is equal to tan theta, right? Or let's see, M of angle K1 is equal to this thing, right? So 1 K1. So your negative 2 is equal to tan K1. So K1 is equal to arctan negative 2 plus 180, right? So K1 is equal to whatever the answer is there. So arctan minus 2 plus 180. So we get that this is 89. This is 89.68, right? Let me double check something. Sorry. This is 116.57, right? This is K1. It's 116.57. So you know that this angle here is 116.57. You know these two angles are supplementary angles in a straight line, right? So which means this angle K2. So K2, this angle here. So you know that K1 plus K2 give you 180 angles in a straight line. So you know what K1 is. K1 is 116.57 plus K2 is equal to 180. Therefore, K2 is equal to 180 minus 116.57. So your K2 is equal to 180 minus 116.7. So it's 63.43. So this K2 is this angle here. Is this angle here. 63.43. So you know two angles. This angle here and this angle here. So you have this. If you look on the small triangle, you know two angles, you're missing one. So you put this missing angle N. We'll call it 180 minus the sum of those two angles. 63.43 plus 53.13. So your N is equal to 180 minus that. So 180 minus 63.43 plus 53.13 minus, you get that your answer is 63.44 degrees, which is the same. So you have at least three options to get this right. So you're done with this one. I'm going to clean the parts now, and then we'll do 3.5. So let's enter this. It was 63.43. So I'm going to clean that, and then we're going to go to 3.5. Okay, so now we're going to do 3.5, right? 3.5 reads as follows. Determine the equation of a line which passes through L and is parallel to SN, right? Write your equation in the form y is equal to mx plus c. Let me read this again. 3.5. Determine the equation of a line which passes through L and is parallel to SN, right? Write your answer in the form y is equal to mx plus c. They want an equation of a line that passes through this thing, right? Passes through this point but parallel to SN. What does it mean? So they're saying this line is parallel to SN. What does this mean? It means the line and SN have the same orientation. So that means they have the same orientation, which means if SN is like this, the line that passes through this one will also be like that. Which they should have the same. They should have the same orientation. You can see that they should have the same orientation. That's what parallel means. It means they have the same orientation. Fine. So here, this is how this line will look like. It will have the same orientation as that one. That's what that means. So if two lines have the same orientation, which means the angle they make with the x-axis will be the same, right? The angle that they make with the x-axis will be the same, which is this angle also make 53.13. If they make the same angle with the positive x-axis, right, that means they have the same gradient. Because this angle of inclination, which is the angle that they make with the positive axis, is determined by the gradient, right? It depends on the gradient, on the amount of your gradient, or the size of your gradient, or the size of the slope. So if these two have the same orientation, which means they make the same angle with the positive x-axis, you you can see this angle should be the same. Therefore, this angle depends on the gradient, which means this line of yours that you want, that passes through L, and that line SN, they have the same gradient, which means the gradient of your line is equal to the gradient of SN. This is because the line, if you say line is parallel, your line is parallel to SN, which means they have the same orientation. Right? They have the same orientation. If they're vertical, they'll both be vertical. If they're horizontal, they'll both be horizontal if two lines are parallel. We know that this one is like this, it's slanted like this, which is the other one should also be slanted in the same orientation. Therefore, if they're slanted the same orientation, they make the same angle with the positive x-axis. And that angle that they make with the positive x-axis is the angle of inclination. Right? It is the angle of inclination. Then, the angle of inclination depends on the gradient. If these two have the same number of inclination, which means they have, because you said that when you're finding the angle of inclination, m is equal to tan theta. So this angle here depends on the gradient. If they have the same angle as I said they are here, that means they have the same gradient. So, we know that m of the line is equal to, the gradient of the line is equal to the gradient of Sn. We know the gradient of Sn is equal to 4/3. We discovered that a long time ago, it was 4/3. So you want a line that passes here and have that gradient. So you say y is equal to mx plus c. You know what m is. Y is equal to 4/3x plus c. So the only thing that you need is c, because if the line, you know this line has the same gradient as that one, which is, you know the gradient. You have a point there, right? And that point is what? Minus 4 and 1. So you can find the value of c. Say y is equal to this mx plus c. The y is 1, 4/3 x minus 4 plus c. So you have 1 is equal to minus 16/3 plus c. So we have 1 plus 16/3 plus c, or equal to c. So solve this. 3 plus 16/3 plus c is equal to 19/3. So your equation is y is equal to 4/3x plus 19/3. So this is the equation of the line. So which line is this? Is this line here. So y is equal to 4/3x plus 19/3. So that's the equation of a line. Done with that question. Move to the next one. 3.6. What are they saying at 3.6? Calculate the area of LSN. So they want you to find the area of triangle LSN. That's what they want you to find. Which triangle is this? Is this one here? Is this triangle that they've given us? This, and that. And this one here. So you know, if you're given a triangle, I will try to draw this triangle again. So this, it looks something similar to this. The 90 degree here. So you have 4√5. We have 2√5. You have 10, right? So this is L, S, N. Fine. So you have this end here to be 63.43. Fine. You can find that one as well. I don't know. So we can say it will be 18 or 90 minus 63.43. So this angle here is 26.57. It's 26.57. No problem. So it's up to you. You have many options of calculating this area. So to find the area of a triangle, look, You have L, you have N, you have S. You want the area, I'll do it in all of these, or all angles. Area of triangle, let's say LSN, right? Actually, let me do it like this. Let's say LSN is fine, right? You can use angle L. So you want the area of this. I'm going to do it from all angles, right? Let's say the area of triangle LSN is the same as area of triangle LNS, which is the same as area of triangle the other way. I don't know which one. But let's go now. The area of what? Let's say of SLN. SLN. I'm calculating it sitting here, right? It's going to be half of the side that I'm including this angle, which is LS times LN, sine of the included angle, sine of angle L. So this area is equal to what? Triangle, area of triangle SLN will be equal to half of LS. What is LS? It's 4 root 5. What is LN? It's 2 root 5. Sine of angle L. Sine of angle L, which is 90 degrees. So here's the area. So you can punch this and get your area. Let me punch it. So it's a half of 4 root 5. 2 root 5 sine 90 degrees. So you get that your area is 20 square units, right? So the area of triangle SLN is called this, 20 square units. Then let's say now I want to calculate the area sitting here. So the area of triangle LNS, which is LNS, is equal to what? It's going to be half of the size that, half the product of the side that include this angle, this side and this side, which is to be LN times NS, sine of angle N. So we should be half of LN, which is what? 2 root 5. Angle S, what is angle NS? What is this angle here? NS is, this length is 10. Sine of angle N, which is 63.43, I think. Yes. So punch that, 0.5 of 2 root 5 times 10 times 10 sine 63.43. You get that your area is called 20 square units as well. You can do the same thing sitting here, right? If you're sitting here, your area of triangle, what? L S N will equal to half of these sides that include that angle, this side and this side, which is LS times NS sine angle S. Now, if you punch that, it should come out the same. You know what that angle is, 26.57. So it should come out the same. So we're pretty much done with this one. So we move to the next one. So the area of this triangle, all of it, is 20 square units. Done. I'm going to clean this board and then we'll do 3.7. Let's clean the board. So now we're doing 3.7. So 3.7 read as follows. Calculate the coordinates of point P, a point which is equidistant from L, S, and N. So they want us to find the coordinates of P. Right? What is P? They're saying P is a point that is equidistant from P, from L, S, and N. So they want us to find the coordinates of P. What is P? P is a point equidistant, right, from L, S, and N. So they want us to find the coordinates of this point P that is equidistant from L, S, and N. What does equidistant mean? Right? What does equidistant mean? Equidistant means equidistance mean equal distance. That's what they say. Equidistant means equal distance. So the point P that they want you to find, they want it to be same distance. So if, let's say, in this case, you have S, right? Say you have S here, which is that. You have L, which is this. You have N, which is N is sitting here. Right? So what they want is, let's say this is N here. So they want a point that will be equal distance from all three of these positions. Let's say maybe it was somewhere here. So let's say this is your P. Your P should be same distance here, same distance there, same distance there. So all these points, P is equidistant from all these points. So P is equidistant from L, S, and N. So they want you to find the coordinates of more like of the midpoint of all of them. That's what they want you to find. That is what they want you to find. So, how do we go about this? You might have seen something similar to this in the past. So, equidistant just means find the coordinates of P of a point P such that it is equally distant from all three of them. That's what this thing means. So, and you might have seen properties like this before. You have seen them, I'm sure you have seen them maybe in a rectangle, right? Because a rectangle have the diagonals of the rectangle. They all meet at the midpoint. They all bisect, right? So, if you were to extend this, let's say same distance as this to this side, right? You can see that you have some sort of a rectangle. You can say this and this. No, this is 90 degrees because it's what we were given already. But now, if you maybe can extend something like this, right? You can see that you have some sort of a rectangle here. So you can do the same thing here. Okay, let me try to extend it to here. There. So we have some sort of a rectangle. So what that means is, if you can find the distance midpoint between these two, right? Between S and N, it will also, you will get, if you find the distance between this, the midpoint between these two, it will also be the equal distance from L. Because if you look at it, it more or less forms something like a, if you try to extend like this, it forms something like a rectangle. So you know that the diagonals of a rectangle, they all bisect, right? They all meet at the midpoint. So now, if you find the midpoint of SN, that will be a point that will be equidistant from all 3 points. Right? So what do we do? Let's find our midpoint. So the midpoint P is the midpoint of what? Of Sn. So x coordinate of a midpoint, or let's say x coordinate of P is equal to x coordinate of S plus x coordinate of N divided by 2. And the y coordinate of P called y coordinate of S plus y coordinate of N divided by 2. So x coordinate of P is equal to the x coordinate of S, which is what? 4, plus x coordinate of N, which is minus 2 divided by 2. And the y coordinate of P is equal to what? Y coordinate of S, what is the y coordinate of S? It's 5, plus y coordinate of N, which is 3, all over 2. So the x coordinate of P is equal to this, and this is 2 over 2 is 1. And the y coordinate of P, this and this is 2 over 2 is 1. So the coordinates of P are 1 and 1. Done. These are the coordinates of P. So the coordinates of P is going to be a midpoint, which is going to sit somewhere here. It's equally distant from all 3 of them. And if you can extend it to that direction, this to that direction, it forms some sort of a square. And you know that the diagonals of a square bisect. Right? So these are the coordinates of P. So go to 3.8, the last question. What are they saying at 3.8? They are saying calculate the angle P. Right? They are saying calculate angle P in LPS. Calculate the size of angle P in LPS. Where is LPS? This is L, P somewhere here, and S there. So if you look at this, it's 1, right? And the coordinates of P, I said is 1 and 1. So this line is horizontal, it's parallel to the x-axis, right? So what do we know? So we know that if you can extend this further, this angle is the same as that one there. So this will also, let me just clean this. No, here, this angle here is 53.13. So if you can extend this angle, you know that this is 53.13. So this angle and that angle are equal. What do we call them? They're called corresponding angles. Yeah. Looks like these 2 angles are corresponding. And therefore you will know what this one is on this side. Because this is a line. So these 2 angles in a straight line, they add up to 180. So your 180 minus 53.14 would be the angle P, which is here. Because you want LPS, you want this angle here. So it should be 180. So, because like I said, this one and that line, this line is horizontal. If you join them by a line, you will see that these 2 are horizontal, right? You can see that these 2 are on the same line. They are horizontal, right? So if this was making, if the angle of inclination was 53.13, then these 2 will also make the same angle. So you can find these 2 because you know this and that are corresponding angles, and these 2 angles they add up to 180. So your angle P will be called 180 minus 53.13. So your angle P is called 180 minus 53.13, which is 126.87 degrees. So it is that. Done. So we're done with question 3. So we'll move to question 4. I hope this is clear to you as it is to us. Thank you for watching.